Welcome, everyone. This PowerCast is Fight Cyber Threats with IBM Encryption. It is sponsored by Help Systems, and our speaker is Sandi Moore. Sandi has been with Help Systems for approximately 15 years. She is their principal security consultant, and she specializes in cybersecurity. Sandi, you want to take over?
Absolutely. Thank you, Fred. All right. Welcome, everybody. Thank you for joining us today at our webinar. And as Fred said, we're going to fight cyber threats with IBM Encryption. Talk about that. So I am Sandi Moore, lead or principal security consultant with Help Systems. I've been working on IBM for longer than the 15 years I've been with Help Systems. I've worked in a number of capacities, support, training, testing, and then now as a subject matter expert, sharing with everyone the power system security tools and helping to find solutions that are going to add up to the requirements of any given company that we work with. So, and I'm also pleased that I have also gone through some training for a certified data privacy practitioner. So really have dived into expanding my knowledge in data privacy and really embrace it. So it actually is right on topic with what we're going to talk about today. And that's really encryption in general of data on IBM. But first, a little bit about Help Systems. We've really made a huge investment in security provided through our security products, or globally recognized as PowerTech. We do have comprehensive services as well for both IBM and AIX, and making sure that customers have assistance in getting those security projects implemented, because you don't always have the bandwidth, the staff to actually get it done. Sometimes it's a knowledge gap, and really being able to bring full circle the implementation is critical. We're part of the PCI Security Standards Council, so we're really trying to keep track of what's going on in the industry and making sure that we understand. Of course, we also provide security education through webinars like this. We also have the ability to issue CP credits for that education through NASBA, so helpful there. And we're also a publisher of the annual State of IBM Security Study, and that webinar is actually coming out in April. So really taking a look at the data on customer systems that we evaluate and providing you a look into where things are right now with security. It's proved to be a very vital tool in helping shape the direction that not only we go as a security provider, but also IBM. And so this information is extremely valuable. So hopefully you'll be able to watch for that and join us for the unveiling of the 2022 results. So really what I want to talk about first is what data needs protection. So, obviously fighting cyber threats with encryption, you have to address first what needs to be protected. And, there's a whole host of information that is stored on IBM, and it tends to be the server record. It's the primary database, whether you're actively working on it and have applications, or you just use it as simply as your database of record. There's important information on these systems. And so we have to start thinking about what needs to be protected. Whether you're going down the road of PCI data with credit card information, more customers I talk to, I find that is actually going away. There's not as much PCI information stored on IBM, which is fine. That actually makes life a lot easier. But there's still a lot of information on those systems. We really want to consider what's out there. PII data, where you've got social security numbers, birth dates, electronic personal health information. So anything that falls under that, if your employees' information about what health insurance company, which plan they're on, those types of information can also be deemed as sensitive and need some protection. Bank account numbers, even routing numbers. If you have a combination of a bank account number and a routing number, somebody's got some good information that they can take advantage of. User IDs and passwords. Passwords goes without saying, that definitely needs to be protected. PIN numbers, payroll information, whether it's someone's wages, their home address, those are the kinds of things that you don't necessarily want to have publicly available on your system. Driver's license numbers, financial data, intellectual property. This is a big one. When we talk about, the systems and what they're being used for, I've talked to a lot of customers in the manufacturing realm, and they've got their trade secrets, their product formulas, their cost of parts. That all goes into making the business successful. So really, that is another piece of that information. And really, if you come down to it, it doesn't necessarily have to be one of these set examples that I've provided. It's anything that would be considered confidential to the organization, its employees or customers. So I might not even be able to think of all the things that might be deemed sensitive that would need to be protected. And what are you going to need to protect it from? So really, the threats to the data is whether it is for theft for the purpose of selling, so personal information. There's been numerous cases of employees selling off information. Once I was standing in the Starbucks line in the Chicago airport in O'Hare, and I had some guy in front of me telling a story to the guy he was traveling with about an employee that had downloaded the customer database into a spreadsheet, printed it, walked off, quit, and then sold that list. So you never know what people are going to do with it. Sometimes that data is merely compromised by ransomware. So if that confidential data has been attacked, and they're not just using ransomware to hold the data hostage, they're hoping for payment because they also are stealing the information and holding it exposure hostage. So if you don't pay, they're going to expose that data. It can be for your competitors. It could be state-sponsored and industrial espionage. It happens. It's happening more. There's actually a video that I strongly encourage FBI just released on some state-sponsored cyber espionage, and it's actually quite terrifying. If you want, ping me in the chat or in the Q&A panel, and I'll get you a link to that video. It's eye-opening. So there are things that we need to be concerned about. Of course, the fact that you're concerned about your information is not the only reason you might want to do some data encryption and actually protect that data. There are quite a few mandates that require data encryption. So it's not just something where it's nice to have it in place because you know you've done your best to protect your information. There's actually quite a few requirements. GDPR explicitly calls out encryption, PCI DSS does, as well as HIPAA. So it's not that it's, suggested, they explicitly call for it. So 2 articles in GDPR explicitly talk about encryption and how that is going to help you to meet that. And GDPR, even though we're here in the US, if you're doing business with anyone in the EU, GDPR applies to you. So we've got a lot of webinars at Help Systems that talk about GDPR and how that will apply. That can be helpful as well if you're looking at that as a requirement. PCI DSS and encryption, a couple different areas where that is called out explicitly as well. So if you're falling under that, definitely want to investigate that. HIPAA also requires that EPHI has a mechanism to encrypt and decrypt that information as well. So it's a requirement. If you fall under that, there's definitely going to be that need. There's more that actually have popped up over recent years. The New York cybersecurity regulations as well explicitly call out encryption. So again, if you're falling under that, it's a topic that you have to address. There's even more, and actually this one was popped up on my radar last year with NACHA. So, and this is to do with the ACH transactions. And this summer, their second phase of this requirement is rolling out. So any ACH volume greater than 2 million in 2020 will need to be stored in an unreadable state, so encryption. So this is one that I've actually had pop up recently, and a lot of customers don't realize this requirement is going to apply to them. They rely on other parties to inform them. Someone I just recently worked with actually had their bank that they had changed over to a new bank said, hey, this is coming. So, unfortunately, when those regulations come out, we have to abide by those. Another aspect there is cyber insurance. So they very often do require that you have measures deployed to prevent data breaches, but also encryption of that sensitive data is becoming more common. So you need to make sure that you're reading the fine print on those policies, and they expect you to protect the data and do your best. And if you still have, after all your layers of protection are in place, you still have a breach, then they might help you out. So doing the due diligence ahead of time is going to save a lot of problems in the end. So, all right. So obviously a lot of reasons there beyond just the desire to protect the information, because your company's reputation is important. So what about encryption itself and what it actually entails? A little bit of background. I'm sure that most of you on the call here are familiar with it, but I like to revisit it just because I think it's important to kind of get back to the basics of it. So that encryption is actually the basic of it is that the process of encoding the information to protect it from unauthorized access. Hides the true meaning of the message, but it doesn't actually take away its existence. And so to do that, the data is encrypted with an encryption algorithm and then a key that is used to be able to do the encryption, and then appropriate key to do the decryption as well. So plain text before, you can read it as is. The ciphered text is unintelligible. The meaning has now been hidden, but with the appropriate key, you're going to be able to get back to that plain text. So if you're authorized, you can get to it. If you're not authorized, you're not going to be able to know what that information is. A lot of different terminology in tied to that encryption. Cipher, pair of algorithms that perform the encryption and decryption. There's a whole host of ciphers, including AES, and each of those ciphers have been around for quite some time. Some of the older ones actually shouldn't be used. They've been broken. To date, AES is the most popular cipher, and for what I understand, the AS256, which is the highest cipher with that, has not actually been broken as of today. So always best to keep up with the technology and make sure that you're using the strongest methods in order to make this encryption the strongest it can. The keys themselves control the operations of those cipher algorithms. So the output is manipulated by the key, and the key is represented by bits. Symmetric key cryptology is the form that actually takes the sender and receiver share the same key. So you've got the same key for both the encryption and the decryption. The key has to be kept secret, or it is no longer going to protect it. And so it is often called secret key cryptology. Asymmetric key cryptology implements key pairs. And when there's a public key that is used to encrypt the information, and then a private key is used to decrypt the information. So that's also known as public key cryptology. More than you guys may want to know, but it can be helpful. All right, so strong encryption is actually, the definition changes over time. This is not something that is static, because as things are compromised and methods are broken, that needs to be changed. And so the strength of your encryption method is influenced by a number of factors: the choice of your algorithm, so the length of the key itself, and then the secrecy of the key. Some of that's obvious. If the key's not secret, it's been exposed, and it is no longer a very strong encryption method. So the recommendations with this is to really make sure that you're using an industry standard encryption standards, and then you use sufficiently strong keys. So longer keys, randomly generated, make sure that you are using a strong algorithm. What does this all mean for IBMI? What we really have to consider is that, the system is one giant database. It can be accessed through a number of tools, and those tools can be either by rogue employees taking advantage of that access, or external hackers. And I like to remind people that hackers, the bad guys, don't have their own profiles. They're using your employees' profiles. So whatever they have access to, that the employees have access to, that's what those bad guys are going to have access to as well. So those databases are accessible through so many interfaces. You've got command line access, SQL, DFU, database tools, query, ODBC, JDBC, client access. So we really make that information really readily available and easy to get to. So that's a concern. The backups themselves, backup media often passes through hands to reach its offsite storage location, whether it's a tape, DVD, portable drive, it's on-site storage. You have to consider when it's in transit, is it being protected? And then on that offsite storage, how secure is that? And then of course, the actual transmission of our data. So, the internet makes things a lot easier. We're using it right now. I'm able to speak to you from potentially thousands of miles away. And that information is all being shared over the internet, and it can be monitored, read by others. So we have to consider when that data is being moved, are we protecting it, whether it's going through FTP, email, or HTTP. What are we going to do with that? So how are we going to tackle that? So for IBM, encryption is possible. It is definitely something that is going to be a good solution for protecting the information and controlling who has access to it. It's a lot easier than you might think. It is sometimes very daunting to consider a major project like that. Any security project is going to have some potential learning curve and some time involved with it. The nice thing with that is that if you are required to meet a compliance mandate, you can prove that you're in compliance. You can show that the data is encrypted and that you've done the right thing by it, and you are actually have it encrypted and controlling who is actually able to see the information. You have to consider, though, that not all encryption solutions are created equal. And so not all methods are going to actually be a good fit, and you've got to evaluate what is available. So one of the cool things with IBM is that we've got some technology that continues to be enhanced and added to the system. One of the things that IBM introduced at V7R1 is a field procedure, which really has taken encryption on IBM to a new level to make it a simple process that is actually going to not require, in most cases, changes to your applications. It's non-invasive to your database, integrates with all OS functions, and can be controlled programmatically. So programmatic controls are who's going to be able to see the data, what version of the data are they going to be able to see? And being able to integrate with all the operating system functions, it makes it application agnostic. So regardless of how somebody's going to get to your information, if they're not authorized to see it, they're not going to get that. So there's no back doors to this. The field procedures, of course, became available in 7.1, which is actually crazy. It's already been released. Retired, released in 2010. So this has been around for quite some time. A lot of people don't even realize that it's available. What did the field procedures do? They're FieldProcs. It enables the technology to simplify your encryption projects. So application changes don't need to be made. The FieldProcs are actually attached to the field in that database file. So there's no extra steps, there's no triggers, no programs that have to be added. Your applications don't have to be modified to say, oh, go call this program. It's automatically done. It stores the encoded values for those fields. You don't have to change the data type, the length, or the CCS IDs. So making life easier. It's supported for any DDS described physical files and SQL defined tables. So as long as you fall under that and you don't have those system 36 tables, you're good. And you'll be able to do this. And the cool thing with the FieldProcs is you can do multiple fields in a single file. So really making sure that each field that has the sensitive data is going to be defended. And it also works with multi-member files. So it really was a game changer for making encryption available to any environment. The FieldProcs are called when there's a database insert, update, or read operation. So when new data is inserted, as soon as that user hits save, it's automatically encrypted. So now it's encoded in that DB2 file. It is now defended. That FieldProc is called again any but user that goes to read the data. And depending on how you configure it, the user is going to see that full information and fully decrypted view of the information. Or if you want to programmatically decide, hey, I don't want this user to see this, they're not authorized, they're going to get masked data or partially masked. Really, example, I always fall back to a social security number. The last four of a social security number. That's all most people need to see in a database, unless you have to have the full to produce a 1099 or something like that. So really that field procedure, because it's at that database level, makes it very streamlined. Adding and removing field procedures, there's some rules around it. There is the alter table with the library file name, alter column for the field name, and then the set FieldProc program library and program. So you do have to make sure that there's no other locks on the file while the alter statement is run. Make sure you have object alter authority to the file as well as use to the FieldProc program. So if you don't have authority, you're not going to be able to get this done. Performs mass encoding encryption of those field values. So it can take some time. So you want to make sure that you're actually adding it to batch or submitting it to batch. So you've got encrypting a single file with 1 million records, could be a while. So definitely want to take that into consideration. In order to remove the field procedure, you're going to do that alter table, alter column, and then drop field procedure. So again, performs a mass decoding of the field values. So again, could take some time. So definitely something to consider when you're adding and removing those field procedures to implement this process. For viewing the encoded values, any regular database tool can't be used to actually see that encoded value because the values are automatically decoded. So you can't use display physical file member. So you can actually use the view the hex encoded values with the hex encoded function in SQL. So there's an example there for you. I can't read that, but that is a social security number from the employee master file. Not legible to me. I don't know if you guys can read hex, but it's there. All right, so encoding events. So when you are going to call that field procedure, when is this going to happen? So any native record level updates and writes will call the FieldProc to do the encoding. Any SQL insert and update statements. Some CL commands will as well, including copy file, star DFU. Query processing, so when you do a select, the lookup value is only the lookup value itself is encrypted. So you'll be able to do that select statement. And then encoded values, key values on a set lower limit, chain, etc. So this is where that lookup value again is encrypted. So that is going to happen automatically on those encode, and that field procedure is called. And then the decode event. So when it's going to invoke the FieldProc on those reads. So again, native record level reads, SQL select and fetch, query processing, any report writers, file transfer utilities, including FTP, client access, Surveyor 400, reading CL commands. So display physical file member, copy file, and any other trigger processing. So for before and after images. So this is all going to invoke the field procedure for the decode. There are some custom coded solutions. It can be difficult to encrypt data yourself. So you have to have some, there's definitely some considerations that you need to employ here. So it can be difficult. It can be very time consuming to implement a custom encryption solution. I've actually talked to a number of people who started it, got in to the pretty far into it and realized that this was not something that they wanted to own because of the requirements, but also the ownership down the road and managing it over time. IBM's APIs are complex, require a lot of research to make sure that you're implementing them correctly. Any major application changes may be needed to encrypt and decrypt the data when you're doing a custom solution. Keeping in mind if you change any database types, numeric to alpha, needed to expand field sizes to accommodate the encrypted data, needed to modify application programs to accommodate those database changes, plus the cipher functions. So encrypted data can also contain special characters that interferes with the emulators. So you have to keep that in mind as well. Very often, custom key management solutions don't meet PCI requirements. So make sure that you know what your mandates are and that what you're doing is actually going to meet those requirements. You would hate to get down the road to the end of your data encryption project and discover that it actually is not going to pass those audits. Audit trails are going to be non-existent or limited. So, really, you have to have the data tracked. You have to know what is actually being done with the tool. And then there's also the problem of separation of duties. A programmer knows too much about a custom solution. And so, not that I don't love programmers, they make my life fun and challenging every day. But, auditors don't appreciate think about the fox guarding the hen house. They know too much. There's a probable compromise at some point. And so this is definitely a challenge that you may or may not want to actually tackle. So what's the alternative? A commercial IBM encryption solution. That is really where you've got someone who has actually gone through all of those steps, made all of the considerations, and has built the tool to integrate into the operating system, has considered all of the ramifications, has made it so that you are not the person doing the setup of the solution and know too much intimate knowledge of how it's created, and takes that the questions away from that. So with the commercial encryption solution, like our PowerTech encryption for IBM, you should expect that the tool will have that full functionality to it that is required. When data is inserted and updated, automatic encryption into that DB2 database, and then the automatic decryption as well when someone reads it. So with PowerTech encryption, you've got authorization lists that users can be granted access to that fully decrypted values, or you can have them restricted to simply the masked values. Or if they're part of the public and we're not on one of the authorization lists, they're going to be denied access at all to read that particular field. So making that automatic and ensuring that regardless of which interface they're using, those field procedure programs are going to check to see what they're authorized to, and give them only the view of the data that they need. Within the tool, you've got the ability to set policies for PCI, so that separation of duty. Not everybody needs to have full access to all implementation of the tool. So creating that separation of duty. Field procedure programs are already written. They're ready to go and will seamlessly integrate into your applications. Extensive security controls. So making sure that users cannot take advantage of their access to the system. Think about all object authority. All object users are a nightmare for auditors and the people who are trying to justify why their users all have all object authority. Having security controls that can deny that access to view the data just based on all object authority is very powerful. The ability to have key management included in the application to be able to truly create the keys, make sure that they're stored securely and that they're used as intended, but also key rotation. So if you have to maintain those keys and rotate periodically, PCI requires rotation of keys. How easy is that process? So making sure that that is done per the requirements, but also making it that it is doable by the administrators of the tool. And of course, audit logs and alerts. You have to have audit trails. You have to know, especially when we're dealing with a security tool that is defending the most sensitive data on the system. So knowing who's making modifications, who is actually changed the key, who has added or removed a field from encryption. So making sure that you're constantly aware of what's happening with it is just as important as defending the data itself. If somebody has the ability to go and expose the data intentionally, you're going to have that audit trail to show that it was done and who it was done by. So within the PowerTech encryption tool, you've got that global policy setting. So that PCI dual control, separation of duties, and full control over the policies themselves. Can the keys be used for encryption? Can the key be used for decryption? Integrated key management that can actually also integrate with a third-party external key manager. So keeping everything to the IBMI team to manage, or do you want to have that key manager as part of an enterprise key management solution? So both ways are supported so that you don't have to be stuck with one answer or the other. The security control. So who's going to be able to manage those keys? Who's going to be able to encrypt and decrypt the data? And how is it going to look for that end user? So really, and who's going to be able to make those changes and decide how it looks for those end users. And of course, the strong encryption methods. We talked about the strength of the encryption using AES 256, 192, 128, or the TDS algorithms. So having choices, but really wanting to make sure that you're using that strongest encryption method that applies to your requirements at that time, right? So the database field encryption, being able to define and manage your fields in the field registry. So you tell the software which fields need to be defended, which ones are going to be activated. You may not activate everything all at once. Some may be inactive until you've decided how you're going to control who sees the data and who doesn't. The automatic encryption for those database fields using the field procedures or column triggers if necessary. Most field types are supported. So, whether it's pack numeric, zoned, alpha, date, time, graphic, those field types are going to be supported. So there's that wide span of requirements. I mostly work with alphanumeric and data decimal fields, but there are other fields that may actually have sensitive information that does need to be defended. So, and then the field size as well, small and as well as large field sizes. So really that flexibility of ensuring that the fields that need to be defended are going to. IFS encryption is included as well. So really the ability to have those commands to encrypt and decrypt stream files on the IFS. What a lot of companies and users forget is that they've got this sensitive data in the fields, in the databases, and they print that information into a document that is now stored in the IFS. So that data, if it's printed in the clear and not masked, it is still sensitive and it is now stored somewhere else. So having that IFS encryption in place allows you to encrypt and defend IFS directories and the files within it. So overlooked, underappreciated part of the IBMI is that IFS. Backup encryption as well. So being able to encrypt and save entire libraries or specific objects. So taking that data, and when you save it to a tape that you have to send off to your vendor for evaluating the application, you want to make sure that that data is actually defended on that, that tape. So using the save encrypted command instead of your save command. Backup encryption is slightly redundant when we're talking about systems that already have field level encryption or IFS encryption in place. Because when you back up that data, in your databases that it's encrypted, it will be encrypted on the backup as well. IFS encryption the same. So when you save that data through a regular save, it is saved in that backup. So you would not necessarily need to change your regular backup routines because it's redundant. You've already got the data is going to be saved in that encrypted form. So backup encryption is a very specific requirement in some cases. You know, really, encryption in a box is a good way to describe the tool because it does provide you with everything you need to deploy the encryption of those fields. So you're going to have that full key management in place. You don't have to figure out how to create a key manager and where are you going to store the keys and how are you going to manage the keys. You've got that easy access for the conditional decryption and masking. So really being able to dial in on who should be able to see this data and what form are they going to see it in, full decrypted or partially decrypted and masked. The administration interface is there as well. So being able to use dashboards to see the data on the results of your encryption is helpful as well. So you've really got that full tool all built together and ready to go. The deployment is actually very quick. I actually worked with somebody yesterday who I think they were ready for this really long drawn out process and that there was going to be this high learning curve and it was going to be so challenging. And they were shocked that in the hour we had set aside, we had everything configured and ready to go in a field encrypted, and we were able to access the data with different profiles and see the results of that encryption and that masking immediately. So really having the ability to roll this out quickly without having to do overhaul of the system is incredibly helpful. Minimally invasive. So really the ability to do this without causing requiring changes to your applications, changes to the interfaces, and making sure that we're not causing more work than before. And of course, you're not having to code for the encryption and decryption. This is all automatic in the background. So really that full availability of the entire tool right out of the box. Having the global security policy settings, meeting those requirements, the integrated key management, the security controls, the strong encryption method, the field encryption itself, defining how it's going to work, defining your directories, and then applying any of that backup encryption gives you that full interface. So let me show you guys. I have a couple of slides. I actually don't have a ton of details on it, just because I think that I don't want to overwhelm, but really being able to identify and drill down how this is going to be for the end user. So being able to quickly identify which files in your libraries you need to address gives you that ability to see how many of the fields in your file you've already defined. So how many fields are there? How many are in our registry? So what has been added to the PowerTech encryption already? I think it's very important to be able to identify that. So you may have 6 fields in this file. You've got 2 copies of it here. 6 fields in our CDPCM file. 5 of those are in the registry and 5 are active. We've got a copy of that. We've got this CRPCM CBU. That customer master file has the same 6 fields. I'm assuming they're the same. There are none in the field registry. There are no field and there are none active because you don't even have them defined yet. So easily being able to do an inventory as to what have I done with this? Have I finished my rollout of my encryption of the sensitive fields? Makes this easy to add it as well. So being able to list out and see which fields are there in that file gives you easy access to determine what you need to actually encrypt. So quick shortcut. So making this as simple as possible to define in the software what you're going to need to actually encrypt and then decide how it's going to be viewable to your users. So with a simple Option 6, adding that new field entry, you're going to be able to configure it into the tool right from that listing from the file. Really, we try to take an approach of easy to manage, easy for your folks that are going to come behind you after you get to retire, you hit the lottery, and making life easier for all involved. So really taking that field information and plugging it in for you, no copy and pasting, no having 3 sessions open to go back and forth and create this configuration, but really having the ability to identify the field and make it within the tool easily identifiable as well. So taking that library name, the file name, and the field name. So that combination of information is critical. So when you're looking at a list of all the fields listed in the software, you're not guessing, is this the social security number from this file or is it this file? You know exactly what you're dealing with. Prompting for the keys. So once you're starting this and adding it to the encryption registry, being able to pull up and grab the data encryption keys that you've already created and applying them for this particular field. And then deciding if you have to use a separate key for decryption or not, or leaving it with the same key for both. And then of course, choosing your algorithm method in the encryption mode. So critical component of that, how are you going to encrypt it? I personally have never had anybody actually do anything less than AS256. So really that is the strongest method. And unless you had a particular situation where you were limited in your encryption algorithm, I would definitely recommend the AS256. So choosing that and then deciding who is actually going to have access to that data. So through the authorization lists, we're going to be able to decide who's going to be able to see that full view of the field, who's going to see that masked view of the field. And using IBM object level authorities, those authorization lists are going to have public excluded. So only the users on the authorization list are going to see that view of the data that you want them to. Group profiles, application profiles will be included there as well. So making sure whoever needs that data in the clear, for example, to run those 1099s, they're going to need that full view of the data. So making sure those profiles are on that authorization list. Caching will speed things up. So, sometimes they're quite, well, now we're having to decrypt the data. We have to do a select over, 100 records. And how is that going to work? The authorization list caching allows us to speed things up. So when that user accesses that first record in that database, we're going to cache the authorization list that they're on. So we're going to know what authority they have. And so we're not going to have to check at every record that they access once they've done that. So absolutely makes things more efficient. For testing purposes, I usually have this turned off. So production environment, absolutely want to use that caching to manage the authorization that the user is going to have. The masking itself, you really have a lot of control over how that's going to look for the end user as well. So standard with the social security number is that you're just going to show 4 digits on the right, none on the left. So, your customer service rep or the person who's doing benefits really doesn't need that full social security number to validate who they're talking to. Just tell me your last 4 of your social. Now I know who you are. The rest of it, you can choose what it's going to be masked with. So I mentioned before, which type of field you're going to be encrypting makes a difference for that masking value. So a character field here in this case, we're going to be you're going to be able to use any special character you want, a number, etc. So user's only going to see the last 4 of that social if they're on the partially masked, that masked authorization list, and the rest of it's going to be, in this case, masked with the hashtag or the pound sign. It's funny, the generations where they look at that and we say pound sign and they say hashtag. Same thing, just trying to make sure that all of our audiences here know what I'm talking about. Not authorized field values. So if you're not on one of those 2 authorization lists, what are you going to be able to see? We don't want you to see any of that social security number. So we're going to fill in that value in this case with an asterisk. So fully masked, you cannot see the actual plain text of that particular field. All right, so what does that look like for the end user? So application data in a non-protected view, you've got a full view, the fourth column over, Social Security number. So you can see a whole bunch of bogus Social Security numbers there for my test database. And the user here has obviously been on the full authorization list. So they get to see that full Social Security number. Now, protected view, user that is not authorized at all, which we changed Robin's access to it. So now he is not on either of the authorization lists. He's fully denied access, not authorized to everything but the name field. So asterisks for that full, some of those with the bank number and the credit limit, those are numeric, data decimal fields. So they have to be masked with a number. So it's got some all fives, got some asterisks in there. Application doesn't care. It is the correct type of, the masking is going to match with the type of field. So it will still display appropriately. Now for those users that are going to have that mask view, again, quick change there, be able to show just the last four of the Social Security number. With the credit card number, you've got the last four and the first two. So really that flexibility of making sure people see enough of the information to do their jobs and not so much that they are now exposing sensitive information. One thing I want to point out is that the RTATM profile that I'm showing in all of these examples has all object authority. So the ability to mask the data from those all object users is critical. Just because you've got that all object does not mean you should be able to see that information. So really expanding that and making sure that programmatically we're denying that access. So very powerful. Now, of course, we've got smart people in the crowd here, and they're going to say, yeah, but what if I do use query 400? Okay, well, because it's application agnostic and it's done at the field level with the FieldProc, it doesn't matter how you request that information. It is still going to show you the view of the data that you're authorized to, regardless of how you request it. Display physical file member, SQL, DFU, any of those methods are going to still honor that masking. So just because you're not through the application. And that really is one of the downsides of using an application to merely mask information, is that if that only applies if the user's coming through the application and they're in the application they're supposed to be in. There's so many other ways to get to data that you have to make sure that you've considered that. Is the data still going to be defended if they are going through a backdoor? If you're using any other tool, whether it's through ODBC or JDBC, I mentioned DFU, you need to make sure that that is going to be honored when that data is pulled off the system. The user knows how to use FTP or has access to Google to figure out the FTP commands, and you're not defending FTP. I do a get and pull the entire database off the system. You want to make sure that when that happens, if you'll let it happen, that data is not going to be in the clear when it arrives onto that user's PC or that server that's pulling it off of there. So no backdoors to be able to get to that data. All right, so kind of just circle back, that integrated key management, really, I can't emphasize enough that it really makes life so much easier for the end user, and really pulling that tool together to have all of the pieces you need to implement this encryption on your system, establishing that overall policies, who can create and utilize them, who's going to be able to create and manage the keys, doing that key rotation that may be required. Organizing the data encryption keys logically. So we use a key store, which is an IBM validation list object, to be able to manage those data encryption keys in those key stores and encrypt that key store where it's stored. So really just taking that full application perspective of making sure each thing that needs to be utilized or available to make the tool work is included. So really being able to have that full ability to know what's happening, making sure that you're able to easily implement it and you've got everything available to you immediately. Auditing, I mentioned that we had some dashboards. So being able to actually pull that data in, visually see what's happening with it through our help systems insight. So that dashboard, you've got the ability to pull up the audit details and see each audit entry. And you can also pull in statistical information about how many fields you have with field procedures on them. If you're tracking and logging decryptions of any specific fields, you can track that. If somebody has tried to actually access an IFS file in an encrypted directory and they're not authorized to, how many times has that happened within the last week or whatever time frame you select? So being able to pull that data and have that visual of what's been happening in the system, rather than digging through the audit log, having that visual representation can be very helpful. All right, so some key considerations, and I always chuckle when I say that because, you know, the key to encryption is the key, right? So when you're choosing an encryption solution, you need to keep in mind your compliance requirements. So when you're deciding what is actually required of you and the solution you decide to go with, is it going to meet those requirements? Custom tools written by your programmers may not meet those. The strength of your encryption method, talked a lot about that. Having the ability to have that audit trail. So that is going to be important. You need to be able to show who's made what changes and what is happening within the tool. Your implementation time. Is this going to be a project that is going to last a year, or you're going to be able to do it in a couple of weeks? And the ease of use. It's all about time. A lot of us are, well, most of us, actually all of us, have too much on our plates, and we have a lot of responsibilities. We wear many, many hats. So do you have the time to figure out a complex solution, or to create that solution that is probably going to be very complex? So ease of use is a big part of that. So really thinking about all of those is should be a big part of your decision making. And when you go to do that, the PowerTech encryption is just one part of our security suite. So really, security is should be a holistic approach in deciding all of the things that apply to you and what your requirements are that you need to meet. There's some basic security that every single environment should have in place. And so really making sure that you have at least the basics covered to defend the company. If you've got that sensitive data, regardless of what it is and how you define it, if it's sensitive to the company and it's valuable, it's worth protecting. A lot of companies will start with a server health check, and that vulnerability assessment with our security scan can help you get started to at least see where you're at. What have you missed? What are the things that, what system values do you have set properly, or have you overlooked? So really that tool, which is cool because it's free, is going to give you that top-down view to get you started. What do you need to do on the system? How are we going to make this happen? Do we have vulnerabilities? And give you the starting point of, okay, let's get this project going. What do we need to do with it? And start from there. Of course, if you already have the encryption needs, that's something that can be attended to immediately. But I encourage every customer to use this security scan to be able to get that high level view so you know what's happening. 6 areas of security on the system. We'll do a review with you. It'll take about an hour. This data from these security scans is actually the data that's used for our annual State of IBM Security study. So real data off of real systems. So, participation in this is very beneficial to the IBM community overall as well, not just in your own environment. So big piece of that. All right, so that's kind of towards the end there. I've got about 5 minutes left. If anybody has any questions, go ahead and shoot them over. Looks like Stephen had a question early on, and I think I addressed it. Is the data stored encrypted? Yes, it is. So really, today we're focused on the data at rest. So stored on the system, it's encrypted at rest. we want to start talking about data in motion. So once you decrypt that data and have to send it off, we've got some other tools for that to be able to defend the data in flight. And, really it's about making sure that you've got the best methods available. You have an audit trail of where it's going, when it's going there, and making sure that you've got those bases covered.
Sandy,
All
there's
right.
a question that came in the chat.
Yeah, so it looks like Charlie. Is encrypted data compatible with Prodata's DBU and RDB? I am not, don't know if I have any explicit experience with that, but in most cases, absolutely yes. It is, most applications, it will be compatible. So what we often will do is have you run a trial of the software on your system. If you've got a test system or development partition, to test it against individual applications to make sure that it will use, that it will work properly for your environment. Let's see, authorization list can be created to maintain user have, okay, how can an authorization list be created to maintain user have access? I'm not sure I totally understand the question. So the authorization list is an IBM authorization list. So you, as an administrator, should be able to create an authorization list, and then you will be able to maintain that list. I highly recommend that you audit changes to authorization lists, so that if you have somebody who has decided to go through and update your authorization lists on the system, that you have a record of those being done. That's certainly a something that would be considered as well. Will using SQL from a CL program work? Yeah. Yep. So that user, whatever view of the data they have, is going to be pulled into that CL program. So SFTP, it doesn't matter, as long as if you need to send the data in the clear, you make sure that that profile that's pulling the data to send it through SFTP is fully authorized to decrypt the data. So whatever view of the data is accessible to the user that's sending it, that's what's going to be sent. So shouldn't matter. Okay, so if encrypted data is saved and restored onto a different system, what's the effect? Well, if that system is not authorized for the PowerTech encryption software to be used, you will not be able to use the data. So you basically, again, goes back to not having backdoors. So if I save it and I restore it to a rogue system, you don't want that to be available. That encryption, that field procedures will follow the data when it's restored. So on that other system, it will be encrypted and inaccessible unless the tool and the encryption keys are there to be able and authorized to decrypt. Another question there on rotating keys. You need to bring down the system or jobs which are accessing the encrypted file objects. You will, if you're rotating the data encryption key, will need to have exclusive lock on the file. You don't necessarily have to bring down the system, but you would have to find a time where you do have that exclusive lock on that file is available. So there's definitely some considerations with that. Actively using journal receivers should be taken. That it is going to be sent to the journals in its encrypted state. So if you're using that for replication, you want to make sure that on your HA system that you have the encryption tool authorized and decrypting and managing it on the other, that HA side as well. So. All right, Fred, I think we're at the top of the hour. I've covered all the questions, probably actually created more questions. If you guys are...
And I do have two more. They were in the chat instead of in the QA. The one that's been there for a while is, how does this work with Mimics?
Yeah, so we have a lot of customers with Mimics. So there are some specific steps that we would provide you on the implementation for Mimics, but it works fine with Mimics.
And then the last question that came through chat was, what happens to masked data when a user updates a record in DFU or DBU?
So if this would be actually to a training thing, is if the user is partially masked data and they only update what they can see, that will be a problem. So when a user is updating a record, they need to update the entire field. The user, if they have the ability to update, if they have object level authority to change authority on that database file, they will be able to update it still. They're not going to be able to see when they save it and refresh, it will be masked again. So there's definitely some training that needs to be done for the end users on how, from this point forward, when you update, confirm that the data is entered correctly before you hit save, because you're not going to be able to see it after if you're not authorized.
That's the last one out there. Sandi, I want to thank you very much for this presentation and Help Systems. It's been very informative, very, very informative, even for me. So thank you very much. And I just want to let everyone know that this was recorded and the recording should probably be available next week. So check back then. Thank you much, everybody. Have a great day.
Thank you.